All right, in this example, we just want to determine whether these values are positive, negative, or zero. Okay, that's all we want is to determine whether they're positive or negative or zero. We don't have to know the actual value of these quantities. All right, so let's look at the first one. We have f prime of 1. That's the derivative of the function at x equals 1. Now, the graph of f of x is here in this. It's shown here in the graph, right? So we want to look at what what the derivative of the function is at this point x equals 1. So right about here is this is f of 1, right? It looks like it's about 100. But I want the derivative. So what I want is the instantaneous rate of change. So if I were to draw a tangent line at that point, so if I draw a line, it's kind of hard to draw a line that's tangent at that point, somewhere in there. It only touches once. It only touches the curve once, right? It's just kissing that curve. Kind of hard to draw with my pen. But yeah, let's do this. Let me draw a little line and then move it closer to so it's kissing the curve. Now it's going to actually merge with the curve. It's going to be hard to kind of tell. But we only want to know whether this f prime at 1 is positive, negative, or 0. And the derivative is going to be the slope of this tangent line. Now, the line has a negative slope, right? Because it's going downward as x increases, right? So that means that the instantaneous rate of change, or the first derivative of the function at 1, is going to be negative, because the slope of that tangent line is negative. All right, let's look at this next quantity. We have f of 2 minus f of 1 over 2 minus 1. Well, that should look familiar to you, right? That is the average rate of change between f equals 2, or x equals 2 and x equals 1, right? So we're looking at, here's 2 down here. That's about f of 2, and this is f of 1. And again, if we draw a line, maybe I should get a different color. If we draw a line between those 2 points, the slope of that line is this average rate of change, right? It looks again like this is going to be negative, because the line between those 2 points has a negative slope. All right, next one is asking us to look at f of 5 minus f of 4. All right, well, here's f of 5 right here, and here's f of 4 here, and I could draw a line between those 2 points. Now, I don't really have to draw a line because this is not the slope, right? This is just the absolute change, right? Now, it looks like f of 5 is greater than f at 4. So if I take something greater and just subtract something smaller, then I'm going to get something positive. So this is going to be positive, which makes sense. The change in the function from 5 to 4 is positive, right? It's getting larger. The value of the function is getting larger, so I'm taking a larger value minus a smaller value, getting something positive. All right. D, we're looking for the instantaneous rate of change of the function between 4 and 5. I don't know if I like that question. Let's look at actually at 4. All right, at 4, because instantaneous rate of change is not at an interval. Let's say at 4. All right, I think that's a typo on my part. All right, instantaneous rate of change is at a point. It's not over an interval. All right, so that's I could either have said average rate of change between 4 and 5, or instantaneous rate of change at a point. All right, well, let's pretend it says instantaneous rate of change of f of x at x equals 4. All right, then we're looking at the slope of the tangent line at x equals 4. So if I draw a tangent line here that kisses the curve at one point, then you can see that line has a positive slope. So that means that the average rate of change is the instantaneous rate of change is positive. All right. Next one is asking about f prime of 3. F prime of 3. All right, so 3, that's right here. That's right here at the bottom. I want to draw a tangent line at that point, right? So I'm going to draw a tangent line at that point that kisses the curve at one point. It looks like it's horizontal, right? What is the slope of a horizontal line? The slope of a horizontal line is 0, right? So this one is actually equal to 0. 0. All right, remember that the derivative is the slope of the tangent line at that point. All right, last one here. Where is the derivative of this function equal to 0? Well, we already found 1 point, right? We know that at x equals 3, it has the derivative is 0, right? Because the slope of the tangent line at that point is 0. So are there any other points that are like that? These points are going to occur, many times they occur when the function changes direction, right? You can see here, if we follow the curve, like let's follow it from left to right, right? You can see that the function is increasing, you know, and then I get to a certain point where it turns around and now it's decreasing. And at this point, let me get a red, at this point, I'm going to draw a tangent line, right? At that point, the tangent line is 0. So if I draw a tangent line here, you know, it's obviously going to be positive because the function is decreasing. Over here, it's negative, and then over here, it's positive again, right? So where it's changing direction here, the slope is 0. So at x equals, that looks like a -1. The slope is also 0. All right, and then we know 3. And those are the only two points where I can see that it's changing from increasing to decreasing or decreasing to increasing, right? It's kind of turning around and changing direction. Now, there is another type of point where you can get a 0 slope, where it could flatten out and then increase again, right? And at this point, it would be 0. We don't have any cases like that in this example. But another case would be where it's decreasing and you have a similar situation where, you know, it flattens out and then it continues to decrease, right? Those would be other cases where you could get a 0. So it's not always changing direction. Sometimes it's just flattening out. Anytime you see where the curve is starting to flatten out like that, then that would be where the derivative is either 0 or approaching 0. All right, we have one more example, and I'll see you in the next video.